So here's a suspension bridge. Oh, there's a big suspension bridge accident in India. Did you hear about that? People were walking across this. They just reopened a fancy bridge. Suspension bridge. They just reopened the suspension bridge that had been under repair. A bunch of people went on the bridge over the river, and it snapped in the middle, and 140, 150 people died that got dropped into the Russian River. Super crazy, terrible accident. Okay? Somebody didn't do their math and their physics correct. That they said, yes, it's open, it's safe, but it wasn't. And there's a history of accidents that happen like this. So is math and science important, right? Very much so. And that's why we learn from accidents, but it's not very fun to learn from an accident which kills you, right? You would like to learn before that to find out if something is safe or not. Okay, so here we have a suspension bridge, and one of the ways that we learn how to deal with things in math and physics is we make models, mathematical models of them. So the question is, could we model this suspension cable with an equation? So what we would have to do is we would have to say, well, if I'm going to model an equation, I need to make my axes on here. And I can make my axes anywhere, but in this case, I'm like, maybe it would be nice if I made my axes so my vertex was right at 0, 0. If I did that, could I label other points on this graph? Well, we're told that the distance between those two support poles, right? Yeah, here's the ends of the kingdom. Here's the support there, or maybe this is a cliff. Oh yeah. There we go. That looks kind of fun to walk across. But now I'm scared because that other suspension bridge broke. So, right? In the future, tell your friends, hey, go in the middle and jump a little bit, and then I'll come. Maybe that's not the best. Fight your enemies. There you go. You shouldn't have enemies. You just have them. So you have to fight them. Okay. So there's our picture. We did 0, 0. Can you see that based on this information, I know the x-coordinate of this point? If the whole thing is 140, does it make sense that this point would be at 70? And same thing over here, this point would be at negative 70, because it's symmetrical. Also, I know the y-coordinate. If I made that 0, 0 and the height of it is 14 meters, that would tell me this point is 14 and this point is 14. So because of our choice of where we decided to put our axes of symmetry and where we put our grid points, can you see that it's very easy to see that our vertex is 0, 0. So when writing our equation, we need to put in values for A, P, and Q. And we already have P, I don't even have to write plus 0, and Q. I wouldn't even have to put the brackets around the x if I didn't want to do. This equation is just going to be ax squared. Now, how do we find A? Well, we would like to make an equation where the only thing we didn't know was A. Do we have information that would help us? Yes. We have 2 points, negative 70 and positive 70, comma 14. That means we could plug in 14 for y and 70 for x. Solving for A, we'd have to do 14 divided by 70 squared. That's going to be a small number in the end, but if we try it on our calculator, we get 0.00285. If you simplified it, mathematicians would probably like the fraction better than the decimal, just because it makes working with it easier. So this 0.00285 is equal to 1 over 350. For those of you with a graphing calculator, what did I do? I did 14 divided by 70 squared. I pushed enter, I got the 0.00285. And then many calculators have a button that changes your answer back to a fraction. I hit math, number 1 said change back to a fraction. It changed it back to 1 over 350. I was like, oh, nice. So now I have my final equation. This is the equation that models this bridge. Now, there's more equations. Like, can you see that if you moved your axes to a different spot, you would make a different equation? And both would be right, but this makes it the easiest. You know what these are? So you really want to make sure your bridge, when you do the math right, so that it works out. Okay, questions for practice on this one. So you see how this question, even though it was a word problem, generally people think, oh, because they're words, it's going to be harder. I think this was easier than the last one because you didn't need to do a system of equations. Again, you had to think about what you know, and this idea of, I think we should write it out. This idea of you can plug in a point to find a value, and we had to do that in question 3 as well. We had to plug in the points to find equation 1 and equation 2. That's a very, very, very important mathematical idea that happens over and over again, grade 10, grade 11, grade 12.